The universe never is exactly how you expect it to be. But when you see the truth, it's so much better than you ever imagined. And that's true in all of science. The more you dig, the more wonderful it becomes. Trying to detect planets around other stars is a tricky business in general because stars are extremely bright and planets are extremely faint. So you have to subtract the starlight to be able to see the faint objects orbiting the star. To look for newborn planets is even more tricky because not just planets, there's a whole lot of other muck circling the star that you also could think looks like a planet if you tried to subtract it. Our method is completely different. We're trying to map the gas flow around the star. And we can see where the gravity force from the planet disturbs the flow around the star. So it's a very different technique to imaging, but it's much more straightforward. Normally, when you see gas orbiting a star, you expect it to orbit in a nice big circle. So we can make models of how that orbiting material should look like. And what we find in the observations is there's something wrong. So there's a little bit of an anomaly where the gas doesn't quite orbit in a circle around the star. And we can see that material is orbiting something other than the star. So we can infer the presence of a newborn planet embedded in this swirling disk of material because we can see where the flow doesn't match a simple model. We've been arguing for the last 5 years about what causes all these structures that we've seen with this ALMA telescope. What we showed for the first time is definite proof that these grooves are carved by baby planets. In 2018 and 2019, we made first detections of newborn planets using this method of mapping the gas flow. So we found the actual baby planet itself. Our simulation techniques have a direct crossover to engineering for solving problems like water pollution, tsunami flow, wave breaking, coastal defense systems, wave energy generation. These are all applications of the methods that were developed for astrophysics having a direct translation into being able to solve difficult problems here on Earth.